Welcome everyone. Thanks for joining today to talk about analytical experimentation in the cloud. I'll do a quick overview of what we're going to talk about today. So we'll start with some introductions to ourselves, to Thorogood as a whole, to some of the technologies that we work with, and then we'll quickly jump into the topic that we're here to discuss today, which is analytical experimentation in the cloud. We'll start with an overview, so a high-level overview of what that experimentation is or what it means, how we go about doing that. We'll then quickly jump into the technologies that are involved in analytical experimentation or can help us do that experimentation in the cloud. From there, I'm sure a number of people are kind of interested to get started or have already gotten started. So we'll talk about some next steps for working within experimentation or getting started with this within your organization. So I mentioned we'll do some brief introductions. Presenting on the call today, we have myself. My name is Scott Stieritz. I'm a consultant with Thorogood based out of the US, and I'm joined by my colleague Alan, who's based out of our Sao Paulo, Brazil office. Alan and I both have a number of years of experience within Thorogood across a range of technologies, kind of across a range of industries and use cases, but we're both quite interested in this topic of exploration, like exploratory analytics and experimentation, so we're excited to talk about this. As far as some of the technologies that we've worked with, I've put on the screen here just a couple of the ones. So this is definitely not an exhaustive list, but many of the ones on the screen here are technology firms that we partner with. So I mentioned we're an independent consultancy. That means we don't pick any one technology to partner with or work with exclusively. Instead, we focus on the business goals of our customers. We bring this technology understanding and we help work together to kind of figure out the optimal solution given the use case. So I mentioned I would keep that intro brief. Now we can jump into the topic that we're all here for today, which is this analytical experimentation in the cloud. And I'll start with an overview of the topic. So first of all, what do we even mean by this experimentation? I put together a quick definition of business value-driven exploration using things like ML and AI and advanced analytics or data science or whatever you want to call it. So if we kind of break this into two parts, what do we even mean by business value-driven exploration? We can start by thinking about, is there some way that we can answer a business question that we haven't been able to answer before using data, using analytics? So it's the exploration of this. Is there something new that we can bring to our organization? But that doesn't mean we need to come up with a new invention or have a completely brand new idea every time we want to venture into the world of analytical experimentation. We can also think about, is there something that we're doing within our organization today? Have there been existing attempts to answer a business question that we can approach in a new way or in a better way, given new data that we have or techniques that we have or technologies that we have available to us? Which kind of leads us to the second half of this definition. So ML and AI and advanced analytics approaches. We could probably spend an entire webcast just talking about some of these approaches, talking about implementation of them, those sorts of things. But I just figured I'd throw a quick summary on the screen of some kind of common groupings of approaches. So things like regression or classification or clustering or time series analysis that are commonly applied to these questions. And having an understanding of these approaches, having an understanding of the questions that these approaches can help us answer. So things like how much or how many, is this of one group or another group? Or is there some sort of underlying organization within a population that we can better understand using these approaches? Or given what we know now, what might happen or what should we do next? Having an understanding of those types of questions that we could be able to answer kind of opens our minds to the types of experiments that we might run. So speaking of running experiments, how do we do this? Of course, start with some questions. So these questions could be open-ended. Something probably at the top of people's minds over the past year or two might be, how could the pandemic as a whole continue to impact my business? How might it have done it in the past? How is it doing it now, and might it do it in the future? Or maybe we would have something a bit more directed, like if I change the specific price of one product within one retailer or within one set of stores or a specific geography, how is that going to affect sales of that product? So we could have very wide-ranging open-ended questions. We could have specific pointed directed questions. But either way, after understanding kind of that business question, we want to move quickly into data exploration. So we could do things like correlation analysis. We could just start bringing some of the data onto the screen and build some visuals to represent our data. But what we're trying to do is better understand the relationships that lie within the data that we have available to us, and maybe better understand some trends, kind of identify some areas for deeper exploration or where we can direct some of the focus of our questions. From there, we kind of want to come up with something very specific. So we want to define our hypothesis, something like, if I do this, then something else will happen because of whatever, or defining a relationship that we think may exist between two data points, and we want to prove if that relationship exists or doesn't exist or what have you. So once we kind of have that very pointed, specific question, that hypothesis in our minds, we want to design a test that will either prove or disprove that hypothesis. So part of defining the test is understanding how we're going to test the hypothesis, of course, but also what tools might we need, what data, what might we need, essentially like laying out the plan for running that test, moving quickly then into actually conducting the test. So this is where we're building and training the models, that we referenced on the previous screen, doing some of that true ML and AI and advanced analytics. But from there, we kind of need to evaluate our results. So were we able to prove our hypothesis? Were we able to disprove it? Or maybe we get to a point where we don't have enough information in order to reach either of those conclusions confidently, and we need more data, or we need to refine the approach that we're taking, something like that. But either way, it could lead us to some more directed questions, some more specific questions from which we can then update our hypothesis or design a new test, reconduct those tests, so we can kind of keep iterating through this process until we get to a point that we're confident that we've sufficiently answered the question that we set out to explore in the first place. So a few considerations that I figured I would call out as a part of this experimentation. One is the value of the experiment. So it's pretty important to understand that direct value from any specific experiment isn't guaranteed. When we set out to do the experiment, maybe we're trying to prove a relationship between two data points or disprove the relationship, or either way, we can't know going into the experiment what exactly the results are. So there's no way for us to truly guarantee what the value coming out of that experiment would be, which is why it's very important for us to try to put together a size of the prize estimate. So if we are able to sufficiently answer this question, how much is that worth to the business? And then we want to make sure that our efforts focused on answering that question are proportional to the value that we might expect to get out of it. So that would be the likelihood of answering that question sufficiently and the value of getting that sufficient answer, the combination of those two. We also want to work closely with people tied into the business situation in order to sense check the approach, make sure that the approach itself makes sense, make sure that the results we may get to would be something that's useful. And speaking of working closely with the business, communication is another really important consideration. So where possible, we want to keep analyses simple and interpretable, so that they're able to be understood and actioned upon by decision makers within the organization. And when people are acting upon the insights coming out of this experimentation, we want to make sure that there's a shared, complete view of what exactly the hypothesis was, what assumptions went into it, and what we can and what we can't necessarily infer from the results. So we want to make sure that if we're trying to make data-driven decisions, we truly are making data-driven decisions by having that shared view of the entire experiment. There also might be some considerations in terms of how we enable experimentation within our organization. So one could be kind of some hard, tangible resources. So like data that's available within our organization. We want to balance collecting all data because we don't know today what data might be helpful in the future to run these experiments, but we want to balance that with the value and costs and usability and usefulness of that data. So making sure that we are collecting data to enable this experimentation, but doing it in a way that's organized, doing it in a way that's managed with costs that are appropriately managed, those sorts of things. We also can incorporate cloud technologies, so something that we're going to hit on in some detail during today's session. And we can also think about productionization pipelines. So once I get to something that is valuable, what is the process around getting that into other people's hands? So those are, like I said, kind of some tangible considerations, those resources. We can also think about maybe some slightly less tangible considerations. So enabling a culture of experimentation within our organization. And one of the points there is that an idea for an experiment might come from anywhere. It might come as a specific question directly from the business of, oh, we need to understand this exact relationship, or how much does one of these things affect something else? Or it could come from somebody who has been working with the data, is noticing an underlying trend, is aware of some other data within the organization that hasn't been used in a specific way, but could be. So kind of openness to where the idea for experimentation might come from, understanding that it does need to be sense checked. It does need to make sure that, or we do need to make sure that it is closely tied into business value. Also thinking about reducing barriers to entry to experimentation through things like user empowerment or specific technologies, and also just a general willingness to act on some of the data-based insights that we might get. So I guess tying this back to the value in the top left, we can only get value out of these insights if we're willing to act on them. So being open to the results of these experiments is also something that kind of enables this culture. So I'll toss up on the screen just some common challenges or some quotes I'm sure most people would be familiar with or have heard in one form or another, of just challenges people can run into when experimentation starts, and often when it starts locally, like on people's laptops. People might say something to the effect of, I tested this on a couple rows. I think I've built out a model that's pretty useful, but now I want to train it on the full data set, and that's going to take days. I might try to kick that off on a Friday afternoon because my computer is going to be running with that all weekend, and hopefully by the time I get back on Monday, it will have worked. So something around like local compute power and scalability versus exploring other technologies that might help us there. Or, this works somewhere else. My coworker built this and it was working on my coworker's laptop, but now that person sent it to me. I'm trying to run it on my laptop and all of a sudden it doesn't work the way that they had built it. So, around consistency of environments and some other considerations like how quickly we can change our environments, how flexible they might be, how quickly we can collaborate with people or easily we can collaborate with people on this experimentation. I mentioned clear paths to production. So what the productionization process might look like in the future if we get to something valuable. All of those being some common challenges that we've seen people run into, which kind of leads us to a mindset shift. And when I put this on the screen of experimentation, experimental on one side, operational on the other side, people might immediately think, oh, you're telling me to shift my mind from experimentation to operationalization, and it just doesn't work. It's too slow, there's too much red tape, whatever. And we're not necessarily talking about that mindset shift of we don't want to do any more experiments, we want everything operationalized. The mindset shift we want to make is thinking about how we can build bridges now that will enable moving from experimentation to operationalization for specific use cases a lot easier. So if you need to wait until you found something valuable to productionize something, then there's quite a bit of delay. There's quite a bit of effort that goes into it. Things lose momentum. But if we can build those bridges in parallel, so things like working within integrated tooling, so doing our experimentation in environments that have established pipelines set up, identifying opportunities for parameterization, even if we don't take every single one of those opportunities, same with automation, identifying the potential for our solution to scale out. These are just building bridges to make productionization easier when the time comes. So it's not a mindset shift from no more experimentation, everything must be productionized. It's a mindset shift to how can we experiment in a way that is going to make productionizing easier when the time comes for specific use cases. So after that intro to experimentation as a whole, I'll now hand it over to Alan, who is going to talk about some of the technologies that we might commonly use for doing this experimentation within the cloud.
So now I want to talk about a few cloud technologies that help us run these experiments in our organizations. There are a lot of tools out there, and they're constantly changing and evolving and coming up with new features that may help us address different needs in our organizations. This is by no means an exhaustive list, but I do want to mention the ones on the screen here. So we have Alteryx, Dataiku, Azure Machine Learning, Google's Vertex.ai, Amazon SageMaker, and Databricks. And these are all cloud-based tools that will help you prepare data, build models, different algorithms, train the models on the prepped data, deploy them so they can be consumed, and manage and start automating all of this process, right? They each have unique features and strengths and give us a lot of flexibility in terms of how technical the end users have to be in order to use these tools to conduct successful experiments. We are seeing these cloud technologies really help companies break barriers to entry in order to incorporate data science and machine learning into their business processes and analysis, and that's very valuable. Most of these tools, like I said, will offer low code or even no code capabilities sometimes to some degree. Like we see here, this is Dataiku, this is Alteryx, and Azure ML Designer has this drag and drop feature. And they really help users create and test hypotheses much more quickly. But more than that, they help a lot with the interpretability and communication aspects that Scott mentioned before, because things are easily visualized, and then that really helps to foster that culture of experimentation and build up the confidence to incorporate these more advanced techniques into your business. At the same time, these tools will also let you create machine learning solutions that are very, very advanced in the data science and data engineering aspects. And most of them will make use of this concept called a notebook. The most famous one is this Jupyter notebook, which you can run in Azure ML, for example. And this is where you write your code and execute your code. But also you can include a lot of commentary, even some charts and tables to help you visualize the results throughout the experiments. Here are a few examples. Like I said, this is a Jupyter notebook. This is SageMaker and Databricks, all using the same kind of front end and this notebook concept. So how do these tools work? What kind of functionality do they provide? First of all, they allow you to connect to data. You can use sample files or connect to many different data sources like data lakes, databases, or something more customized, even like an API connection. After you connect, you're able to explore your data, check some descriptive statistics like means, standard deviations, distributions, then prepare your data. Some typical steps can be filtering out some extreme outliers, filling in missing data, splitting the data sets into train and test sets, things like that. And then finally start testing different algorithms and building your models, right? Like we just saw, this can be done using a mix of drag and drop features, but also code in different languages like R or Python or SQL. And the nice thing is that in these tools, all of that can be done in a collaborative way, meaning you can have multiple people working the same experiment at the same time, see each other's code, etc. And lastly, some of these tools will offer something really neat called AutoML or automated machine learning, which will test different algorithms and features and parameters for you and help you choose what works best for your use case. So that can really help speed things up sometimes. All of this code will then be run in the cloud. You can set up all kinds of infrastructure to run the data preparation steps, the model training itself, which can be a pretty heavy step sometimes, like Scott was saying, may take a weekend otherwise. Do the scoring of new data when it comes in. Again, this is very flexible to accommodate different data processing needs. You can start with something really basic, but you can also build your solution to take advantage of distributed processing technology like Spark, which is available in Databricks, for example, and get great performance out of that you wouldn't otherwise have in a local laptop. You can also visualize and present things along the way. Like we saw, you can plot all of these data exploration steps as you design the experiment, visualize the workflows of the data preparation with the drag and drop features, and actually see the results of the experiments themselves, right? You can use and leverage a lot of data visualization libraries within the languages that we mentioned, but also these tools will offer different native features to help you present things in a nice looking way. What else? As you build out your experiments and as this culture grows, you'll be conducting different experiments at the same time. So there's a lot to manage, right? And these cloud tools will let you manage everything that you build. You can make changes to the infrastructure that's running your code. You can track the performance of each model, monitor the accuracy of the predictions that you're making. And as you begin to scale, you can make these models more robust and more useful by adding different parameters to them. And finally, these cloud tools are great because they provide you with the foundation to what we call productionization, right? So as Scott was saying before, productionization or industrialization is not something that comes right after experimentation, but it happens in parallel. As your experiments grow and start giving you the business value that you're looking for, you want to be creating frameworks and investing in these frameworks to operationalize these models. And these tools, these cloud tools, will offer different ways of packaging the models so they can be deployed and then consumed. And at the same time, you can start integrating that with your enterprise architecture, connecting to your data lake, maybe a database or a web application that you want to embed this model in. And as you're incorporating these models into your processes, making them operational, managing the applications, the code, the infrastructure, the parameters, all of that is what we call DevOps, or in this case, MLOps, right? And then we have a number of other webcasts, including one coming up next week about this topic, in case you want to check it out. And that's it. That's basically how these tools work. So what comes next? How do you get started on this experimentation journey? Or if you've already started, how do you keep growing? First, you need to think about what you're designing these experiments for. I don't want to be repetitive here, but thinking about how you envision these models to work. Some of them are meant to be one-off. You run it, you get your answer, you move on to the next one. Or others may be more reproducible. You want to run with new data every time. You need to think about what's the priority in each use case. So business interpretation, something that makes sense to everyone versus getting a very strong predictive power. And that's where you start getting into the more black box kind of algorithms and more complex math behind everything. And how much you want things to be operationalized, right? So everything we were just talking about. And the answer to these questions will help you determine how much data engineering you need, how complex in terms of data science and statistics you may need to get, whether there's any data visualization needs associated with everything, how it all fits with your architecture, or whether you need to adapt your architecture somehow. Also, how much you want to invest in adopting these DevOps and MLOps frameworks. And with all of these considerations, you can think about different project structures or ways to shape initiatives around experimentation in your department or in your organization. And finally, to wrap up here, there may be some extra considerations like around or outside, in a way, the experimentation itself. Right? We use this concept a lot of these 4 pillars with our customers to help identify where there may be challenges or gaps to be addressed. So quickly about each of these 4 pillars. In people, you want to think about what are the best ways to organize internally and with possible partners to better create this culture of experimentation. You need a combination of skills in data science, data engineering, data visualization, and also a lot of domain expertise in your industry. So finding a balance between all of that can be quite challenging sometimes, and you may consider running some training to address some gaps, for example, or shaping some initiatives around the people side of things. In data, we want to think about getting people access to a lot of data in an easy and democratic way. You want to think about whether you have enough data, or you may want to consider acquiring some more or go after collecting more data. And once you do grab more data, are you ingesting it quickly enough to allow these experiments to run smoothly and keep the pace of the experiments with good quality data pipelines and things like that. Tools, we talked about different tools, but we want to make sure they're flexible, they're scalable, they provide the ability for different people to collaborate. And also, we want to make sure that they align to the skills that people already have. So, for example, one organization has a really strong culture around R, the language. You want to make sure that the tools that you adopt give the support to take advantage of the skills that your teams already have, for example. And lastly, under process, the whole field of data governance and security, balancing this mentality of give everyone access to all of the data with security, but also talk about what the processes are to give people access, the roles involved, and basically how everything is going to relate to that productionization and industrialization that we talked about. What are the processes involved? What are the frameworks that you're going to adopt? This is pretty much it for the content. And like always, we're available. This is our contact information. Feel free to reach out for any questions or discussions, anything related to this topic. We'll be happy to talk to you. And see you next time. Thanks a lot.